This week, a double dose, which means that we do 2 chapters, chapters 2 and 3. And chapter 2 is on supply and demand, and gives you in a nutshell and a number of things that are discussed in chapter 2 will also be discussed in chapter 3. So what you will learn in chapter 2 is a basic description of the supply and demand model, where we use equations and graphs to represent supply and demand, and we will analyze the market for goods and services using this model. Now then we will come up with a couple of extensions, and we will introduce the concept of elasticities, which are a very handy way to summarize properties of the supply and demand function. So, to start, what is a market? Now, a market is characterized by a number of features, which is, okay, what product or service is being sold on the market, at what location is the product sold, and in which point in time is the product sold. So, for example, pizza delivery. Pizza delivery at 8 o'clock in the morning is a different market than pizza delivery at 8 o'clock in the evening. So you can imagine that the demand for pizzas at 8 o'clock in the morning is pretty low, but there is a giant market for pizza delivery at 8 o'clock in the evening. But the demand for pizza delivery in Groningen is probably a lot higher than the demand in Uithuizermeeden. So a market is characterized not only by the good or service that is sold, but also by where it is sold and when it is sold. And markets, what they do is they facilitate exchange, so including economic resources, final goods, and services. So the market is really a coordination device. So what are the supply and the demand for a good? The supply is the combined output of a good of all producers in a market who are willing to sell the good. And the demand is a combined amount of good that all consumers are willing to buy. And the 4 key assumptions underlying our simple supply and demand model are the following. So we focus on supply and demand in a single market. So pizza delivery at 8 o'clock in the evening in Groningen. We assume that all goods sold in the market are identical. In practice, that often doesn't hold true. So you can have a market for CDs, but for example, if you have this CD, you probably find it very different. So this is the Black Crows, and this is a CD by Mac Hutchison. Both are CDs, but they are differentiated. So you might like the one and not the other, or vice versa. We abstract from that here. We assume that all goods are identical. If you want to go to study differentiated goods, that's done in the follow-up course. So we also assume that there's no price discrimination. So all goods sold in the market sell for the same price, and everyone has the same information. So a kilo of bananas cost the same to everyone, say €2 a kilo, and everyone knows that a kilo of bananas cost €2 a kilo. So if you have grocery stores like the Albert Heijn, you get personal discounts with your bonus card, which leads to price discrimination. Some people pay 20% less for a kilo of bananas than others, and you don't know from each other who pays which price. That type of price discrimination is something that's not part of our basic model. And we also assume that there are many producers and many consumers in the market. So no firm or consumer has market power. No firm or consumer is big relative to the aggregate size of the markets. Everyone is really small. Now getting to demand, what factors influence the demand for a good? First of all, there's the price. If the price of a good is higher, you suppose that you expect that the demand for that good is lower. The number of consumers, the more consumers there are, the higher the demand for a good will be. Also, consumer wealth, how much money people have to spend, will influence the demand for a good. And it may be that for some goods that impact is different than for others. So if your wealth increases, you are likely to buy less noodles, but you're maybe likely to buy more cars or to go more often on a holiday. And it also depends on consumer tastes. So consumer tastes, they may also be different in different times. And the demand for a given good also depends on the price of other goods, and where we distinguish between goods that are complements to the good that we consider and goods that are substitutes. First, we will focus on how the price of a good influences the quantity that's demanded by consumers. So we single out one element that affects the demand for a good, and that one element is the price. And by changing the price and seeing how the demand for a good changes, we derive something that is called the demand curve, which describes exactly that, the relation between the quantity that's demanded at a given price of the good. And here we hold all other factors like the consumer taste, the number of consumers, we hold it constant. So how does that work? Suppose that we have the market for oranges and we want to map the quantity of oranges demanded by local consumers at different prices. And first we do the graphical exposition, and after that I will go into the mathematical representation. So first assume that the price of oranges is $6 a pound. Well, that's an incredibly high price and no consumer is willing to buy oranges at that price. And this is then called the demand choke price. It's the price that kills all the demand for the good. And it's always the point where in our little graph the quantity is 0 and 6 is the price, so it's the intersection with the y-axis. So always remember, you should label your graph, you should put names on the graph on what's on it. So you should have here the quantity on the x-axis and the price on the y-axis. And the demand choke price is the intersection with the y-axis. Now what happens if we decrease the price of oranges? Rational, we expect that if the price is lower, if anything, more people will demand oranges. And in our example, of course, this holds true. So as the price drops to $5, then 400 consumers will like to buy oranges at this lower price. So the total quantity demanded at this lower price of 5 is 400. If we drop the price further to 4, then demand increases further to 800, then it increases to 1200, and so on and so on. And if the oranges are for free, if the price is 0, then we are in the intersection with the x-axis, and the total quantity demanded is 2,400 oranges. So what we've done is we've derived the demand curve, the relation between the price and quantity of oranges. So you feed in a price, say 3, and what comes out is the quantity demanded, in this case 1,200. Now it's important to know that we essentially draw the graphs the wrong way around. So we put the cause on the vertical axis. So we start with a price and then we ask, okay, if the price is 4, what is the consequence for the quantity demanded? So the effect is on the x-axis. Now, we did it graphically, we described the demand curve graphically, but we can also do it in a mathematical form, and that works as follows. So the demand curve that was given graphically on the previous slide, mathematically the form is as follows. It's QD is 2400 minus 400p, which means if the price is 0, so you plug in the price is 0 here, then this term vanishes and the total demand for oranges is 2400, the intersection with the x-axis. And also if we plug in the price equal to 6, then we have 6 times 400 here equals 2400. So 2400 minus 2400 is 0. So this is telling you that at a price of 6, that's the demand choke price, because the resulting quantity demanded is 0. So, and we can write it in the form of the demand curve, but we can also solve this equation for P to have the P at the left-hand side, and then we get what is called the inverse demand curve, which tells you if we have a certain quantity, what is the resulting price. And in this course, we will use both representations. Now, what about the other factors that influence demand? So we've now focused on price, but a couple of slides ago, we also discussed that consumer tastes, the number of consumers, the price of other goods may also impact demand. So what we did is we abstracted from all these other dimensions, we kept them constant in order to enable us to graph the demand curve in 2 dimensions with only the price impacting the quantity demanded. If we change one of these other factors, what will happen is that the demand curve will shift. So we will get an inward or an outward shift of the demand curve. Whereas if we change the price, we get a movement along the demand curve. So we distinguish between a change in the quantity demanded, which is a movement along the demand curve because the price of the good that we consider has changed, and a change in demand, which is a shift in the demand curve because one of the other things that we initially supposed to be constant, one of these other things, like for example consumer tastes, they have changed. So let's do a practical example to see what these shifts in the demand curve may look like. We focus on the market for tomatoes and imagine that scientists have discovered that tomatoes have the ability to fight cancer. Well, then before the newspaper article about this discovery, the demand curve is the blue line D1, that's depicted over here. And then what may happen if people read a newspaper article is that their taste for tomatoes increases. They want to buy more of them. It has nothing to do with a change in the price of tomato, but at any given price, they want to buy more tomatoes than before. So the impact of the newspaper article is a shift of the demand curve to the right, like in the new curve D3 over here. Of course, you can also imagine news that is less positive for the demand for tomatoes, like for example, if it is discovered that tomatoes are a source of salmonella. And as a customer, you don't want to catch salmonella. So what happens if people read about this is that they reduce their demand for tomatoes, and we observe an inward shift of the demand curve from curve D1, the initial curve, to D2. So this is how changes in factors that impact demand, changes other than the price, lead to shifts in the demand curve. That completes our discussion of the demand curve, and now we are going to continue with supply. What about supply? And it may be a relief that everything works quite similar in the supply function. So the factors that influence the supply of a good is again the price. The higher the price, the more producers want to supply of a good, the number of sellers, the cost of production, and also the sellers outside options. So you may want to grow corn on your land, but if the price of potatoes is very high, then instead you may want to grow potatoes, and that will decrease the supply of corn. Now, the supply function can also be depicted in a graph where we keep, again, all other things constant. We only change the price, and we draw the supply curve by asking the question, what will be the supply of a good, in this case oranges, at a given price? So if the price of oranges is $2 per pound, then no producer finds it attractive to supply any oranges to the market, and we have this intersection with the y-axis, and the $2 is called the supply choke price because it kills all the supply. If the price increases, then more and more producers will find it attractive to supply more and more oranges to the market. So at a price of 3, demand already, or the supply is already 400, and if the price increase further, more and more oranges will be supplied to the market. And connecting the dots, we will get the supply curve. Again, we can do a graphical representation, but if we want to compute equilibrium outcomes, it's always very practical to also have a formulation in terms of math. So we will do that next. And the supply curve on the previous slide can be written down as the equation Qs is 400 P minus 800, where Qs is a quantity supplied and P is the price. So you can see that the price of $2 is the supply choke price, because 400 times 2 is 800 minus 800 is exactly identical to 0. And since we plot the price on the vertical axis and the quantity on the horizontal axis, we also often use the inverse supply curve, which you obtain from the supply curve by just taking the inverse and freeing the price. Again, if you have a change in the price, you will have a movement along the supply curve, but of course other things may also change that influence supply, and they will be shown as shifts in the supply curve. So it's very much similar if a movement along the supply curve is the response to a price change, everything else is held constant, and we talk about a change in the quantity that's supplied to the market. But if any of the other factors change, then we have a shift in the supply curve, and we talk of a shift in supply. Again, we can give an example. So we again consider the market for tomatoes, and the initial supply curve is equal to the blue line S1 over here. Supply curves are upward sloping because higher prices make it attractive to supply more units to the market. If there's a severe drought, which means that less tomatoes can be grown on a plot of land, we have an inward shift of the supply curve. So we move from S1 to S3. But another factor that may change the supply of tomatoes are technological advances. So for example, assume that a faster harvester is developed, which make it attractive for more producers to supply tomatoes at a given price because the cost of production have gone down. Then we observe an outward shift of the supply curve from S1 to S2 over here. And you can see that the mechanics of the demand and the supply curve is very much the same. And this brings us to the first quiz. And the question is, if demand is given by the equation QD is 100 minus 2P, determine the inverse demand function. Second question, if supply is given by the equation Qs is 50 plus 3p, determine the inverse supply function. And then, having done that, determine the equilibrium price and quantity in the market given by the above equations. If you're not able to answer question 3, but you are able to answer question 1 and 2, you might continue to the next video, because calculating the equilibrium outcome will be the topic of the next clip.